Assalamualaikum warahmatullahi wabarakatuh and good day. Welcome to SEEU 2003. Okay, today we will start a new chapter, okay, chapter 4, which is magnetism. Okay, this chapter will cover 1/4 of your final mark. Okay, so for this chapter, there are two parts. The first part is the theoretical part, which half of it, okay, half mark of your final, and another one is calculation part, okay, which is the magnetic circuit. Okay, so you need to master both to get a good mark in this chapter. Okay, so we start with the first part, which is theoretical. So for theoretical, you need to know the definition, okay, and some equation you need to memorize. Okay, but usually you have to understand the definition and application and the theoretical part. Okay, so if the question asks what is electromagnetism, where is it used? Okay, usually you can answer it used in motor, generator, or transformer. It's basically resulting of electrical charge in motion. Okay. Okay. Basically, you can look at the figure below. Okay. The electromagnetism. Okay. Change from current. Okay. The first figure is from current to flux. Okay. The zero, then dash horizontal vertical line. It is a flux. Okay. Basically, the magnetic. How to represent magnetic. Okay, we can also use solenoid, okay, and in the second figure, and also for the magnet, okay, you can see how the flux move. Okay, so you need to know how to draw this. Okay, if it is bar and there is current, you have to know how to draw it. Okay, we will discuss again later. Okay, the second figure, okay, this one is solenoid. Basically, the current is wind, and as a result, the magnetism is become like that. Okay, and the third part is the magnet, permanent magnet. So the important part here is electricity and magnetism cannot be separated. Okay, it is the same thing. So that is why it's called electromagnetism. Okay, this the magnetic force is caused by the movement of electrical charge. Okay, so whenever the electric particle are in motion, it will cause a magnetic force. Okay, as long as the electrical charge particle moving, you will get a magnetism. Okay, so that is the theory. Okay, okay, the first theory. Okay, we learn about electromagnetism, which basically what happened when the charge moving. The magnetic produced when the charge is moving. Now for the second theory is the Lorentz Force Law. For this theory is basically explain what kind of force produced when the charge is moving through electrical and magnetic charge and magnetic field. Okay, so you can see the formula. So please memorize this formula. F equals to Q. Q is the charge. F is the force. Okay, force produced. Okay, equals to Q is the charge. Okay, in Coulomb. Force is in Newton, and E is the electrical field. Okay, and plus V is the velocity of the magnetic field, velocity of the charge, and B is the magnetic field. So you have to memorize all this. Okay, and you can see that there is arrow at the top of some of the some of it. Okay, F has arrow in there. E also have arrow. It means that it is a vector. Okay, it's not a magnitude number. It's basically a vector. So you have to refer back what is vector. Okay, as you can see from this equation, V, if the charge doesn't move, basically V is equal to 0. So basically force acting on it is only QE. Okay. B only affected if the charge is moving. If the charge doesn't move, you will not have force caused by the magnetic field. Okay. Okay, I have explained this before. Okay, if the if the charge doesn't move, is basically the force acting on the charge is only caused by the electrical field. Okay, but if the charge is moving, okay, the effect of electrical field and magnetic field will produce force on the charge. So you have to differentiate between these two. Okay, so basically if you don't have any electrical charge, okay, you just E equals to 0. Okay, and lastly the Lorentz law can be simplified into F equals to QV multiplied by B. Okay, so you have to refer back to your vector. Okay. Okay, if you refer back to your previous knowledge on vector, so basically cross product needs to be perpendicular. Okay, if the V and B is in the same direction, F doesn't exist. Okay, okay, if the vector V and B, okay, velocity and B needs to be in perpendicular to produce a full force. Okay, if in an angle, okay, if it is less than 90 degree, the force will be reduced, and if it is in one direction with the velocity is the same direction of the magnetic field, okay, the force is 0. And how to know the direction? You use the right hand rule. Okay, you use your right hand. Okay, the thumb represent, okay, the thumb represent the velocity. Okay, okay, the what you call the index finger is represent the field, magnetic field. Okay, magnetic field is basically from north to south. Okay, so you have to memorize it from north to south. So magnetic field of index finger. Okay, and the force is at the point this direction. Okay, you can see the figure. Okay, the middle finger. Sorry, I don't remember what is the name. Okay, so basically you have to know what is velocity. Okay, what is B. Okay, for me is how to memorize it. The thumb is just represent good, right? Very good. Just how you memorize it. This one is usually you do like this, like a pistol. Okay, bang. Okay, that is one way to memorize it. Okay, but try to memorize the right hand rule of Lorentz Force Law, because sometimes the question asks, okay, what is the direction of the charge? Okay, if the magnetic field and movement of charge is like this. Okay, so you have to memorize this. So in theory, okay, in theoretical part, okay, yeah, usually ask about the definition. Okay, commonly ask about the definition of the theory. Then the equation. So you give the equation and what is the meaning of each letter. Okay, then you also need to know how to use the theory. Okay, and lastly the application. Okay, basically how to use the theory and the application is almost the same. So basically the Lorentz law is very useful to design the motor. Okay, if you can see the figure here, okay, at the figure you can see that, okay, there is magnet, okay, there is a coil, okay, rectangular coil, and these are the brushes. This is basically a DC motor, okay, direct current motor. Okay, so this is quite commonly used motor. Okay, so basically, as I said before, the B, okay, the magnetic field is basically from north to south. That's why the direction of the B is, you can see at the blue color, is from north to south. Okay, and then what you see velocity, right? So velocity is basically the velocity of the charge. Okay, what is the direction? Velocity of charge is basically the current. Remember in chapter 1, I said that current is basically the rate of change of rate of moving of current of charge. Okay, coulomb per second. So basically, the direction of the current is the velocity, your thumb. Okay. So basically the direction of the B, okay, magnetic field is from north to south. So therefore, based on this, if the current moving, okay, from my left hand side, okay, goes into the coil to the right hand side, okay, so basically the coil move up, okay. So I will show it to you later, okay, how to use this. Okay, this is another example on how to determine the charge just using your right hand. Okay, if you can see here, the B goes to the right hand side. Okay, so your index finger is this one. Okay, this one is going to the right hand side. Okay, the velocity is going into the screen. Okay, into the screen. So this one goes into the screen. Okay, this one goes into the screen. So basically like this. Okay, this one goes into the screen. Okay, and the direction of charge goes down. Okay, this is applied for positive charge. For negative charge, okay, you have to the direction is negative. Okay, different direction, because Q is in the formula Q is positive, right? So basically, for negative, you have to put negative in the Q. So basically, it is the opposite direction. So be careful with that. Okay, magnetism always involve a lot of direction and vector. So if the direction is to the left, to the right, okay, up or down, it's easy to show because you can use an arrow. But how about goes into the paper or screen, or goes out the paper or screen? So basically, if you see X, okay, X goes into the paper, and if it represent as a dot, it means that it goes out from the screen or the paper. So make sure you know the direction. Okay, this is the standard one. Okay, how to memorize? Okay, basically for me, X is the usually treasure. Okay, usually marked as X. You want to goes into the X. Okay, that is just my way to memorize. Okay, you can use other way. Okay. Okay, before I say that the Lorentz law is used for motor. Okay, how to produce force based on the electrical charge movement. Okay, now I will show you how to use the Lorentz law, okay, to generate electricity. Basically generator. Okay, previously is motor, now is generator. So basically, okay, this is the explanation. It's quite difficult. So in the next slide, I will show you what is this writing explain. Okay. Okay. Now I will show you another application of Lorentz law. Okay. So before this, I show you on the application for the motor. Okay. Basically, with the force produced using Lorentz law, you determine the force produced for the motor. Okay, now I will show you the generator. Okay, how Lorentz law is used to produce the power. Okay, generator. Okay, for generator. So basically, okay, if you look at before, you see X. Okay, you have X. Okay, X, and it said that B. Okay, the magnetic field is basically goes into the paper or screen. Okay, and then you have a wire. Okay, you have a wire here. Okay, and the wire, okay, the wire you move. Okay, let me zoom first. And the wire move to this direction. So if you remember that there is charge here. See, there are charge inside the wire. Okay, fixed charge. Okay, what happen if you move this? Okay, remember Lorentz law. Okay, Lorentz law. If you move, okay, this one is V. If you move this, okay, the charge will experience force. So basically, the charge will move to this direction. Okay, the positive charge will move to this direction. Okay, and the negative charge will move to the other direction. So as a result, this one become positive charge, this one negative charge. So basically, this one is equals to the battery. Okay, like a battery, like a power source. Okay, that is why Lorentz law also can be used as generator. Okay, so this one is basically the explanation on how to generate electricity using Lorentz law. Okay, how to determine the E? Okay, this one is voltage, right? So this one is V. Okay, remember that I said before, this one voltage. Okay, for power source, sometimes we can replace this with E. Okay, either V or E. For load, yeah, you have to use V for voltage. Okay, for source, sometimes you can use E. And usually they use, for this case, use E, voltage. So basically, the voltage across here to here, okay, you can calculate it using this formula. E equals to VB L. L is basically the length of this rod. Okay. Okay, B is the magnetic field. Okay, V is the velocity. So basically, you determine the voltage based on this formula. Okay, just memorize this formula. You can calculate the electromotive force. Okay, basically the voltage induced by the electromotive force. Okay, this one is, sorry, electromotive force. Okay, basically voltage. Okay, so try to memorize how to write this. So we move on to the next, okay, theory, which is Faraday law. Okay, for Lorentz law, the B is fixed. Only the charge is moved. For Faraday law, the B changes. When B changes, you can produce electricity. So what is important, I'll highlight here. Okay, this is the definition of the Faraday law. It's basically the EMF, electromotive force. Okay, let E, okay, represent as E, induced in the circuit is directly proportional to the rate of change of magnetic flux in the circuit. Okay, N is the number of coil. So you have to memorize the equation. E is the EMF induced electromotive force. Okay, this symbol is basically flux. Okay, d flux over dt. Okay, this one is the rate of change of flux. So please memorize this, okay, statement. Okay, the definition of Faraday law. That's it. Okay, and memorize your equation. Okay, so for Faraday law, it's simple because you only have to know the simple theory. Okay, no need to go further. So try to memorize this. Okay, the highlighted. Okay, memorize. So the next theory, okay, is the Ampere law. Okay, what is the use of Ampere law is basically, okay, so this one you have to memorize. Ampere law describe the creation of magnetic field, okay, create B based on the current, okay, continuous current. Okay, for this case you have to use also right hand, okay, but it's called a right hand grip rule. Okay, basically your thumb, okay, if the wire is straight, okay, your thumb becomes the direction of current, okay, from positive to negative, okay, and then this one is the direction of the field B. Okay, you have to show like this. Okay, please make sure you follow this direction. And that one is for straight wire. Okay, how about the coil wire? Okay, or also known as a solenoid. Okay, you can see here in the figure. Okay, if for this case, okay, this one will become your direction of current, and this one is the direction of magnetic field inside the solenoid. Okay, not outside, inside. So inside means that for inside it is from south to north. Okay, from south to north, and then at the outside is north to south. Please memorize this. Okay, so this one for solenoid, this one becomes the direction of the magnetic field inside the solenoid. Okay, this one is the direction of the current. Okay, so we move on to the last part of the theory, which is magnetic core losses. Okay, for this course there are only two core losses you need to consider, which is hysteresis loss and eddy current loss. So hysteresis loss is basically caused by the magnetization and demagnetization of the magnetic material, which produce heat. Okay, so that is hysteresis loss. I will talk about the hysteresis loss later. Okay, and the important part for the hysteresis loss is you need to know how to reduce the losses. Okay, try to memorize these three things. Okay, okay, area of hysteresis loop. Okay, so this one is basically changing the material. Okay, change the frequency of the current, and lastly volume of the material, change the volume of the material. So this one you have to memorize. Okay, so please memorize this for your, okay, please. Okay, this one is the first losses, and the second losses is the eddy current losses. Okay, so what is eddy current losses is basically when you magnetize a core, basically there are small circulating current inside the core. Okay, it will produce a small circulating current. So basically how to remove the circulating current is basically, okay, you just laminate, okay, laminate the core. Okay, basically you, instead of using one solid core, you cut the core into multiple sheet and then put a some kind of insulator between these sheet. Basically the current, the current produced cannot pass through the laminated sheet. Okay, so basically the eddy current, okay, the losses is two, hysteresis loss and eddy current. And how to reduce it, how to reduce the loss in eddy current is by laminating, okay, laminating the core. Okay, also you can use a higher resistive, okay, higher resistive core, or I also can use a lower frequency of current. Okay, so memorize this. Okay, basically hysteresis loss is only for AC. Okay, if the supply is AC, DC doesn't cause hysteresis loss. Okay, so for this case, okay, I will explain you in video. Okay, I will show you. Okay, if you want to read here also can, but it's easier for you to understand with the video. Okay, so I also the same thing. Okay, the explanation is quite long. Okay, again, so after that I will show you the video. So I will explain to you further on the hysteresis loss. Okay, So I will not get into more detail, only just surface. Okay, basically for the magnetism, you usually have B hash curve. B hash curve. Okay, so basically your magnetic material has this characteristic. Okay, B is the magnetic field. Okay, or flux density. Okay, hash is the magnetic intensity. So basically the characteristic is something like this. Okay, at some certain point after you increase the magnetic field in electrical flux, okay, at certain point it will become saturated. Okay, further increase the magnetic flux, you cannot increase the magnetic magnetic intensity. Okay, that is just the characteristic of the core. Okay, different core will give different curve. Okay, different value. Okay, but the curve is almost the same. Basically it's saturate. Okay, so what is this is the B hash curve. So what it mean by what is hysteresis loss? Okay, so hysteresis loss, hysteresis loss only occur when the source is AC. Okay, if DC, no hysteresis loss. Okay, something like this. Okay, as I mentioned before, okay, the history maybe this is the supply plus not plus, because this needs to be AC. And then something like this. This is the core. Okay, so you analyze the B hash here. Okay, B hash. Okay, this one is B hash. Okay, when you analyze the B hash curve here, okay, you no need to understand too much on the B hash curve. Okay, basically, okay, when you apply AC, when AC is like this, right? Okay, time, this one is magnitude, and we analyze the current. Okay, I. Okay, IT. Okay, so when you at this point, okay, this point to this point, okay, this point to this point is basically B hash curve becomes something like this. Okay, remember it almost saturate. Okay, however, when at this point the direction change to this, so basically hash goes to this, goes to that side. Okay, so hash increasing, when the current increase, hash will move to this direction. Okay, become like this. However, when the hash in this point, the current at this point, the hash will move to this point. So what happened is it move. Okay, it will not go to the same direction here. Okay, because of the magnetic, okay, it will lag. Okay, so the cause of lagging, okay, the B will try to maintain its value, so it's try to maintain, but at the end it will reduce. When the hash is empty, okay, at this location, okay, when hash is 0, okay, basically there is still magnetic flux. Okay, and then it move on here. Okay, and hash is at maximum. Okay, at certain not maximum, at certain point. Okay, when hash has value, B become 0. Okay, same as here. It will saturate, but in the different direction. Okay. Okay, maybe something like this. Okay. Then at this point it will change back to this direction, but remember that the B tends to kept at its position. So basically something like this. Okay. Okay, and then something like this. Okay, so we'll move on. Okay, but then it will start again. When we start again, it will goes into this direction path. Okay, it will go to this path. Okay, it will start, okay, like this. Okay, it will move like this. This is what is the hysteresis loss. Basically, if you want to know what is the how much is the hysteresis loss, you calculate the area inside the loop. Okay. Okay, the larger the area, the larger the loss. Okay. Area, okay. P, loss. Okay, so this one depend on the, okay, depend on the material. So different material will give different hysteresis loss. So that is what is hysteresis loss. So make sure you need to know how to explain this. Okay, how it move and everything. So usually you can label it, maybe origin, this one is origin, maybe A, okay, B, C, D, E, F, then A again. Then it will loop, okay, until the source is disconnected. Okay, that's it. Okay, that is the end of theoretical part, okay, which is part 1. Okay, there is also some theoretical in the next calculation, okay, but for that I will show you again in the next class. So what we can conclude today is the first part is the electromagnetism, okay, how it produces. Then you have to know what is Lorentz law, how to use the Lorentz law for motor and generator, okay, what is the direction of the force, what is the EMF, okay, what is the equation and everything. And then you have to, okay, you have to know the Faraday law. Okay, it is important for you to know the definition of the Faraday law, okay, the equation, okay, what is the function, okay. So basically the most important is the definition, okay. Next, the Ampere law and how to use it, the direction, okay, how to know the direction of a magnetic field B, okay. So, and lastly, the magnetic core losses. You have to know the both core losses, which is the eddy current losses and the hysteresis losses. Okay, and how to, okay, how to reduce these losses. Okay, both losses needs, you have to know how to reduce the losses. Okay, that's it. Thank you.